Evening folks, so I just wanted to give a quick update on the progress that I've been making with my Analogue Tach controller. Control and gauge, so you've seen this gauge before. The last video I quickly showed you a demonstration of the gauge working, and I also showed a prototype of everything that was set up on a breadboard. And so yeah, I left that last video. My next steps were to see if I could package the controller up into something suitable for a commercial product, and I think I am getting very close to that being ready. Not 100% of the way there just yet, but we're very nearly there. So yeah, I made a post on Reddit. Somebody had posted in the sim racing subreddit about how they'd got one of these Tach gauges put together, and they were sort of showing it working, and a bunch of people were asking, how do they make it, what's required? And just so happens, I posted a video a couple of weeks ago explaining, how I put it together, the components and some of the bits and pieces sort of required to get that product over the line. So here I am. I have a working controller, this is a prototype, which is why I've printed it in grey. But yes, this is my Analogue gauge controller. It's complete, it works, it's pretty much ready to go, but I'll go over why it's not ready to go in a little bit. But what I wanted to go through first was some of the challenges I had with making this particular product ready for sale on my Etsy shop. So one of the issues that I have with any of my products that I make is you don't want to kind of engineer yourself into a cul-de-sac where you have to commit to one particular piece of hardware. For example, I don't want to make something just for this gauge because there's going to be people out there that don't want this gauge. They will want other types of gauges. So I suppose that the reality is I don't want to go and buy a bunch of these gauges and then people not buy them because it's not exactly what they're after. So ideally what I would do, it is my intention to sell a full kit. If you want to buy this controller and this gauge and, just plug it all in and it's ready to go, that would be ideal. But I also understand that people might want to fit their own gauges. So I had to come up with a solution so that I'm not kind of packaging everything up as a full kit without any kind of DIY options available. What I have come up with is this controller box here. Now, I nearly made this a couple of weeks ago. I thought I was getting very close. And so one of the things that I had to do was basically come up with a solution for, well, first of all, it was making this controller box a completely standalone controller box. I didn't want any hard fixed wires. I didn't want the gauge to be hard fixed to the controller. It's just not very not very handy to have a controller constantly wired into something. So I had to come up with a design whereby everything can be plugged in or unplugged. Yeah, so the challenge there is to have a gauge like this plugged into my gauge controller here, using some sort of form factor that's suitable for everybody. So what I first came up with was, I'm a serial AliExpress purchaser. I buy a bunch of things that I don't need. I have no idea how I'm going to use them, but I think to myself, I could find a use for those. So a little while ago, I bought these RJ11 panel mount connectors, and I've been looking for opportunities to kind of use them wherever possible. Now, if you have a direct drive sim racing base, you will see connectors that look a lot like this, and your pedals or your shifter will plug into a port that looks a little bit like this, and then on the other end you'll have a male connector that looks a little bit like this. And I thought, well, that seems perfect because it's a bit like a network cable, just slightly smaller. So I started designing this enclosure with this in mind here. I come up with like a little sort of a prototype piece of sort of design that I could then retrofit into any of my boxes. And the idea is that I just get this RJ11 connector here, and then I slide it into there, and there we go. We have an RJ11 connector mounted into your enclosure, which is great. Unfortunately, for my use case, I'm using 22 AWG wires for all of my connectors, because I'm carrying 12 volts, and the thicker the wire the better. Turns out that actually 22 AWG is too fat to go into this connector here, which is a shame. So I quickly had to can that idea, because it just wasn't good. I mean, I could just about get the wires in there, but it was such a tight fit. They didn't crimp properly and all that sort of guff. So I'd originally designed this enclosure with just a hole, which is no good. You don't want people having to open up the enclosure to mount your gauge, close it back up again. No good. So I was doing some digging around the internet, and I found this connector here. So this is called the GX12. It's actually an aviation connector. I'm not entirely sure why it's an aviation connector. I guess it's used for plugging in microphones, headsets, or something along those lines. Anyway, it's a GX12. I bought a bunch of these from AliExpress. No, I didn't. I bought a bunch of these from Amazon. 10 was about a tenner, maybe, something like that. 10 includes the male and the female side. So that's technically the female side. And the male plug looks like this here. And so yes, this is a perfect fit. I was super happy when these arrived, because I wasn't actually sure how big they were or whether or not they'd be a great fit. It turns out they are a fantastic fit, because once you've screwed that in, that just sits on there like that, and that's the wires to my gauge. So yeah, really quite happy with that outcome. And I think what I'll do in future as well is my WindSim controller. At the minute, my WindSim controller, which I might put on the screen now, my WindSim controller just has two standard 4-pin Molex connectors in the top of it, and they're fine. Like, they're just normal PC fan headers, and the fans just plug in, but they're not really designed for unplugging and plugging in externally. They're sort of designed for internals. So I'm thinking I might retrofit some of these GX12s. That they're called GX12 because they're 12mm diameter. I might retrofit those to my WindSim controller as well. So that's good. I needed to revise my WindSim controllers anyway, because I wasn't completely happy. The way that I designed the PCBs wasn't great. So anyway, probably more to come on that as and when that sort of revised design comes up. But yes, this is the controller. It's all one completely separate unit, and this is the gauge here, which is obviously, you've seen this, well, maybe you've seen this before. What I've done for this really early version is I've soldered the wires to the male end of the GX12 connector, and these are just bare wires going into these Wago blocks. I'm not sure what you call them, but so this is just my kind of temporary solution. Now, I suppose the idea is, if I sell the controller and the gauge as a single unit, then this will just come hardwired. There won't be any of these blocks in between. But then the other idea is that if you do want to just get hold of just the controller and fit your own gauge, then the controller will come with this cable pre-wired. I'll do a better job of that. Maybe I'll do some braiding or some sort of sheathing on there, but I'm not entirely sure yet. So the good thing with this design is that I can just make that up, or I can make a few of those up, and then sell it with the controller if I need to. I'll just hardwire the controller into this then, and away you go. If not, then I can just sell it as just a controller with that connector. And the idea is it then gives you the option to use whichever gauge you want to use. Now, there are some requirements, and I do need to find out the actual specs of this gauge here, just to make sure that I'm going to advise people on the right gauges to use. But for this particular one, it's got 4 wires. We have a 12-volt input. So that's for the actual gauge motor itself. This is 12 volt for the backlight. This is the RPM cable, and this is just a ground. So I think this is a pretty standard gauge that you can get pretty much anywhere. In fact, you can buy these on Amazon. They're quite a lot more expensive. But so I'm thinking that like with very little kind of jerry rigging, you can get whichever gauge you want to work with my controller. The only requirement really is that it has 12 volt power, because it's a 12 volt supply, and an RPM lead and a ground. Many of them won't come with a backlight. Some of them will. And I think some gauges might even come with additional power requirements. But in those cases, you can actually just double those wires up because it's just a 12 volt input. So yes, so that's what I've done with that. So what I will do now is I'll open up this controller, and I'll give you a little peek inside as to exactly everything that's going on inside here. Nothing too exciting, but it's just in case you're interested, something to take a look at. So yep, I'll be back when I have opened this controller up. So yeah, so here we go. This is the inside of the controller. Now, it's not that impressive, I'm sure you'll agree. There's some pretty basic stuff going on here, but I think it's probably quite interesting for people to take a look at. So yeah, there's all of my, as I say, USB connector straight to the Arduino Pro Micro. There's my 12 volt supply just going into a terminal block here. Here's my switch also going into a terminal block. And then we have the controller here. Now, I have actually, see if you can see here, I did myself a favor when designing this circuit board, and I've labeled everything up so you absolutely, you can't accidentally plug the wrong cables in. So yeah, that's that. Like I'm actually quite happy with how that's turned out. It's not perfect, and actually this isn't the final controller because I'll need to have some mounting lugs on here as well, in case you wanted to put this on your sim rig. I suppose you could just zippy tie it on if you really wanted to, but so yeah, so that is the full working unit. Everything's soldered in, everything's pinned down, and yeah, it's ready to go. I might just show you a quick demo of what this looks like turned on. Nothing too impressive. A couple of lights on there, and the gauge obviously works. So yeah, there we go. Now, oh yes, one thing I should mention, and I think I did mention this in my last video, when I sent these boards away to PCBWay to get made, classic me, just get those made. I mean, it takes a while for them to come over, which is probably why I was sort of eager to get them made up. I hadn't tested this fully. I tested it and it was working, and I was like, oh great, cool, it works, make up a PCB, get it sent over. And then literally the day after I sent the order over to PCBWay, I found that actually this, my design was missing a 10K pull-up resistor. And so what I was doing was it was preventing the gauge from being able to read the signals at a rate that was quick enough or clean enough from the Arduino. So what you can't see on the back of this circuit board is I've retrofitted another 10K resistor that sits somewhere between this transistor here and the ground, and that allows the transistor's signal to be cleaner and more predictive in a way that this gauge likes. Now, that might be a side effect of this gauge being a cheap gauge, but I believe that resistor, that additional 10K resistor that is actually wired onto the underneath of this board, it would be fine for any gauge, any quality of gauge. So it's good practice to keep it on there anyway. So that's what I've done. Yep. So that's my controller board. Might cut to a quick video of this powered up so that you can sort of see how it works. Unfortunately, there's slight restrictions on where I can sell this product to, because, well, certainly when you sell into the EU, you have to sell, if you are selling these devices with its own DC power supply, you have to sell the right power supply for the right country. So if I'm selling into the EU, I need to sell them with EU power supplies. Obviously the UK power supply is not an issue, but I'm not sure if the same rules apply to the United States, but why wouldn't I want to just sell the US DC power adapter? Makes sense, right? So if I do want to sell this to the United States, I will need to source some US DC power supplies. So yes, okay, that's that. I'm just going to switch to some video of this working. So yes, here we go. It's all powered up. 12 volt USB gauge. There's the Arduino, so I have Sim Hub running away. Currently turned off, so I just use this 12 volt power supply button here. There you go. That's a little startup sequence for that gauge, and there we go. That's it. It's in. It's running. And let's just test this. 4,000 RPM, and then 8,000, and increments of 1,000 all the way down again, back to 0. There we go. Exciting, huh? Yes, so something I did just want to mention briefly is, so I have been trying, God knows how I've been trying to get a way to have the gauge power off whenever the Arduino loses power, which is basically whenever the PC's powered off. Now at the minute, yeah, I've got this switch here, and that allows me to control that independently. I think I'll probably always keep that there anyway. But ideally, what you'd also have is, I mean, if there's no power to the Arduino, the gauge might as well not be powered on, right? So I've been trying, God knows I've been trying, to try and isolate the 12 volt supply to this gauge via some form of transistor. Now I believe I can do it quite easily with, a relay, but relays are quite bulky. They're also a little bit noisy. They have a tendency to click, and they can get warm as well. So ideally what I'd use is some form of transistor, a little bit like this. Now this is an N-channel MOSFET. I believe what I might be looking for is a PNP MOSFET of some order, and I can somehow use one of my digital pins on the Arduino to drive it, to close the gate, to turn the 12 volt gauge off when there's no power going to the Arduino. But I've been trying all sorts of I haven't used a P-chan MOSFET. I've been using N for my testing, and I cannot for the life of me get it working. So that is just something to be aware of. The only way to power the gauge off currently is by using the switch, because when you unplug the Arduino like this, the gauge stays powered up. You know, it's not the end of the world, but it's not ideal either. So at the minute, that's just acting like a power supply for that and nothing else. So yes, just something to be aware of. If I manage to crack that, great, because I'll also retrofit that exact same circuit to my WinSim. Again, I'm learning as I go along, but my WinSim also suffers from the same issue. When you turn off, it's got an independent switch, which is fine, but when you turn off your PC and the Arduino is powered down, the fans spin up to 100%, which is not ideal. So yeah, if I crack that one, I'll let you know. I'll put out a video for it, and I'll look to retrofit it maybe into like version 2 of this and into my WinSim controller as well. Cool. I think that's pretty much everything I wanted to cover today. So thank you for watching. Sorry for listening to me ramble on about this. It's a bit geeky, but some people are actually quite interested in it. I find it quite interesting, I'll be honest, otherwise I wouldn't be doing it. So I thought I'd make a little video just to sort of help you guys, or give you guys some information. Hopefully it's useful. If there's anything that you would like to know that I haven't made sort of clear in this video, stick something in the comments. I have so few comments, there's a very, very good chance that I'll reply almost immediately, because it's so exciting getting a comment on a YouTube video. So yeah, leave a comment, that'd be really good. If you like the video, give it a thumbs up, or don't. If you didn't like it, it's entirely down to you. Consider dropping me a subscribe, that'd also be great. I don't put out videos too frequently. I've got a lot of real life work going on, you know, my actual day job, which is why there's that laptop there, but also in amongst all of that, this is all of the ridiculous amount of fans I've had to purchase to make people's WinSims. Not complaining, it's all good. All those on the right hand side are fans that I've sold, and all those on the left hand side, I have 2 fans left and 1 power supply left. and one WinSim circuit board left in there. So I'm very, very busy. I wouldn't have it any other way because I'd much rather be busy than bored. So yeah, there we go. That's a lot. As I say, thanks for watching, and I will see you in the next one. Cheers.